So insects are pretty cool, and a lot of them have very interesting adaptations. Some of them being moths. Moths have some bonkers cool adaptations, specifically to avoid predators. So this is a salt marsh moth, a species of tiger moth. Actually, this is my own picture. I found this at my mother's house last summer. One of the prettiest moths I have ever seen, in person where I live. So one of the main threats and predators of the tiger moths are bats. Bats being like this little brown bat that I found at my place of work over the summer. So theoretically, since these guys are both found in the same area, this guy would be trying to eat the other guy. Now, if you're familiar with bats, bats tend to hunt with something called echolocation. Echolocation being the emission of very high frequency sounds like clicks that they emit. These clicks hit an object and bounce back so the bat can hear it and determine where that object is in the air. Generally, those objects tend to be things that the bat wants to eat, for example, something like this tiger moth. And now the tiger moth very much does not want to be eaten. But tiger moths in particular have a very interesting adaptation to avoid being detected and eaten by these bats. Now, I actually learned about this first in the Silver Wings series by Kenneth Opel. Really great series. A little bit fucked up for a children's book, but honestly, fantastic series, especially if you like bats. So these tiger moths can actually hear the bat echolocation clicks, because bats aren't very quiet. They emit these clicks and they're going all over. So the moths can hear those clicks and they're like, ah shit, there's a bat following me. So when these tiger moths detect the clicks from the bat, they actually emit high frequency clicks themselves. Now, the clicks that these tiger moths make work to basically cause interference with the sounds that the bat is emitting and essentially jam the bat's sonar by making sounds of a frequency that messes with the signal. So the bat sends out these clicks. Normally it bounces off the moth, comes back, and the bat knows exactly where the moth is and goes and eats it. However, in the case of these tiger moths, the bat emits the sound, it hits the moth, and the moth hears it and goes, oh, absolutely not, and emits clicks of its own that jumble the signal, so the bat now has no idea where these moths are. However, other moths also have a different, very interesting type of sound defense mechanism. So this is the white satin moth. This is not my picture, but it's another type of moth. And these moths use something called aposematic coloring, which I've talked about before, but basically they're very distinctly colored in order to say, hey, I'm toxic, I taste bad, don't eat me. So it's a visual warning signal of, hey, you're not gonna like eating me, which works fine in the daylight when they're very visible out and predators will see it and be like, oh, I know this tastes bad, so I'm gonna stay away from it. However, that doesn't work very well in the dark lots of times because it's harder to see them. So, some moths do a different mechanism. Now, I'm not sure if this exact species does it or if it's a slightly different species, I can't remember, but some species of moths, they, instead of relying on visual stimulus in order to say, hey, I taste bad, they rely on auditory sounds. So these moths make a very specific, again, sound click frequency that communicates, hey, I taste bad. So when, again, a bat or something is hunting these moths, they hear this click sound, and maybe this is the first time hearing it, so it doesn't really register. And they eat the moth, and it tastes really bad. So they learn, hey, these moths make this sound of this very specific frequency, and I didn't like how they taste. So now whenever I hear this frequency, I'm not gonna eat these moths because I don't want the bad taste that they make. So it works essentially in the same way as the like different colors and all that to say, hey, I taste bad. But instead of seeing the warning signs, you're hearing the warning signs. So there's another species of moth, perhaps, that maybe doesn't quite look as similar to the toxic moths, but they make sounds of very similar or the same frequency that these toxic moths do in order to trick predators like bats into thinking, hey, I know this sound. This sound means that this bug doesn't taste good, so I'm not going to eat it. And so the moth is left alone because it sounds like a bad tasting moth, even though it itself does not actually taste bad. So yeah, I think that moths are really cool and have some very neat defense mechanisms in order to avoid predators.